especially the students. And today's class is a continuation of the previous class, which is chapter 1, reflection of light. Okay, so today we'll be doing about reflection of light. Okay, now so what is reflection of light? Okay, now we know that one of the characteristics, okay, of light is that it travels in a straight line path. Okay, it travels in a straight line path. Now suppose there's a source of light, okay, like the sun. It emits light, okay, it emits light, and then the light travels in straight line path. Okay, so it's traveling through, say, certain medium like air or vacuum. Okay, and then now this straight line path, what happens is that when it strikes some object, okay, when it strikes an opaque object, okay, opaque object, so what happens to this light is that a part of it is absorbed, okay, means it will be transmitted to the object, but a part of it will be reflected. Okay, so what does it mean by that? It means that this ray of light, a part of it will bounce, okay, will bounce, okay, and as a result there will be a change in direction. Okay, initially it was in a straight line path, but as it hits this opaque object, it will get absorbed, part of it, and part of it will be reflected, okay, in another direction. Okay, so this phenomenon, okay, this phenomenon where it bounces, okay, on hitting an opaque object, this is called what? Reflection of light. Okay, and reflection of light is a result of one of the things that we see around us. Like the sun, it emits light, right? And then what happens now? As it hits the table, the chairs, okay, or any object, now those reflected light, it enters our eyes, and as a result, we see the things around us. Okay, so the objects which do not emit light, the non-luminous objects, we can see them. It is because of reflection of light. Okay, so now let's take for instance a mirror. Okay, a mirror is what? It is a smooth and highly polished surface. Okay, a smooth and highly polished surface, like the looking glass. Okay, looking glass, that is a mirror. Okay, then there are terms, okay, where it is very important to know, okay, especially for ray diagrams. Okay, first, initially, now suppose there's a luminous object, okay, emitting light, okay, then there will be a parallel beam of light, okay, means a bundle of rays of light, but we'll take only one ray of light, okay, to make things simpler. So this ray of light, okay, when traveling through certain medium, okay, this is called what? The incident ray. Okay, this ray striking the mirror. Okay, let's take for instance, okay, a mirror. Okay, the looking glass, okay, that we used. Okay, when we want to see ourselves, right? How do we look? Now that, okay, a mirror is defined as a smooth and highly polished surface. But to represent it, okay, now it is drawn by a straight line, okay, and then with some dotted lines. I mean with some lines here. Okay. Now these lines, this part, okay, it is called the reflecting surface. Okay, reflecting surface means the reflection takes place on this surface. But this, it means this part represents the polished surface. Okay, polished surface, P. Now the detail about mirrors will be done in the later section. Okay. Now for this, now what happens? Now suppose there's a luminous object here. Okay, like the sun or a bulb. Okay, electric bulb, and then emitting light. Now this light, it travels straight line path, and then it hits this mirror. Okay, it hits this mirror. So this ray of light, okay, it is called what? The incident ray. Okay, remember, actually there are infinitely many rays of light coming from the source, but we take only one ray of light to make things simpler. Okay, so we take this one, and then this is the incident ray. Now this point where the incident ray strikes the mirror, this is called the point of incidence, and is denoted by the letter O. Okay, point of incidence. And then we draw a perpendicular line through the point of incidence. Okay, and this is called the normal. Okay, this is called the normal, and as a result of reflection, because it strikes an opaque object, so it will get reflected, right? It bounces. Okay, the ray of light will, as a result, will get bounced, and this ray of light is actually known as the reflected ray. Okay, as a result of reflection. Okay, so we have the incident ray, the normal, the point of incidence, and as a result of reflection, the reflected ray. Okay, now this angle, okay, which the incident ray makes with the normal, now this is called the angle of incidence. Okay, and it is denoted by I. Okay, angle made by the incident ray with the normal, and the angle which the reflected ray makes with the normal, now this is called the angle of reflection, and it is denoted by angle R. Okay, so next, okay, the laws of reflection of light. Okay, the laws of reflection of light. Now the first law is very important. Now at the point of incidence, the angle of incidence is equal to the angle of reflection. Okay, that is angle I is equal to angle R. Okay, so now what does it mean? Okay, what does it mean is this is the incident ray and the angle of incidence. Okay, the angle which it makes. Now suppose this angle, say, is 30 degree, then this reflected ray will adjust in such a way that this angle will also be 30 degree. Okay, so if it is 45, here also will be 45. Okay, so this reflected ray, it doesn't mean that it will bounce in any direction, but it will adjust the angle in such a way that it is equal to the angle of incidence. So that is the first law of reflection of light. Okay, and the second law states that at the point of incidence, okay, the incident ray, the reflected ray, and the normal all lie in the same plane. Okay, which means that this is the incident ray. Suppose this is the normal. Okay, normal is this, and then this is the reflected ray. Okay, so they will all lie in the same plane. Means that if you pass a plane of paper, okay, through this, okay, it will pass through all of this. Okay, means that one of this will not be like in this way. Okay, all of them will lie in the same plane. Okay, so that is what it means. Okay, so the laws of reflection of light. Okay, remember that it holds for any kind of surface. Okay, be it a smooth or rough surface, it will always obey the laws of reflection of light. Okay, now there are two types of reflection of light. Okay, based on the surface. Okay, based on the surface of the opaque object on which it strikes. Now we have the regular and the irregular. Okay, now regular or specular, okay, reflection of light. Now it is when a parallel beam of light, it strikes a smooth, okay, a very smooth and polished surface, and that is a mirror. Example. Okay, so when it strikes a mirror, what happens is that, okay, first what happens, it will have to obey first the law of reflection of light. That is this, okay, like say the angle of incidence is I, then it will adjust in such a way that the angle of reflection also will be equal to the angle of incidence. So as a result, okay, it will be reflected in this way. So after obeying the laws of reflection of light, okay, it is found that the reflected rays are parallel beam. Okay, they are all, okay, parallel beam of light. Okay, so this is regular reflection of light. Okay, this happens when it strikes a smooth surface. But irregular reflection of light, okay, happens when the incident ray, okay, the incident parallel beam of light, it strikes what? A rough surface. Okay, a rough surface. So what happens when this ray, okay, strikes this? It adjusts in such a way that it obeys the laws of reflection of light. The first law, especially, angle of incidence equal to angle of reflection, and then it gets reflected. And then this one also gets reflected. Okay, this one also gets reflected. After obeying the laws of reflection, you will find that reflected rays do not constitute a parallel beam of light like regular. So as a result, okay, rough surface, mostly the objects all around us, okay, they undergo this irregular reflection of light. Okay, image is a kind of illusion. Okay. Now when you look at yourself in the mirror, okay, that is called the image. Okay, means the one that you're seeing, okay, that which is yourself, okay, that is the image. Okay, so now scientifically, okay, image is what? Now they have defined it as a result, okay, formed, okay, due to reflection or refraction. Okay, image is formed due to reflection or refraction, but there are two ways, okay, either they meet at a point or they appear to emerge or to meet from, they appear to meet, actually they meet at some point, or they appear to diverge from some point. Okay, so image, there are two types, real and virtual. Okay, now when we say actually they meet or appears to meet at some point, now this can be understood only with the help of ray diagrams. Okay, so real image is after reflection or refraction, they will meet, actually they will meet exactly at some point, but in terms of virtual, okay, after reflection or refraction, they will appear to meet or diverge, means coming, okay, almost diverging from that point. But okay, when you try to explain it, okay, like without ray diagrams, okay, now for example, okay, if I placed a mirror here, okay, there are special other kinds of mirror other than the looking glass, that which is the plane mirror. We have the concave and convex mirror. Now if you place a concave mirror here, okay, and I am standing here, okay, and you place a screen, okay, at the back, okay, now at some position, okay, at certain position of concave mirror, you will find that it will be formed, okay, on the screen, okay, it will be formed, okay, and that is a real image. Okay, but for example, okay, you placed a plane mirror, okay, the looking glass. If you and there's a screen, okay, and then if you look in the mirror, and then however you will find that no image is formed at the back of the screen, which means that a virtual image, okay, cannot be obtained on the screen. Okay, so that plane mirror, it always produces what? A virtual image, means when at the screen there will be no image formed, but a real image also will be obtained on the screen. Okay, so that is what it means. Okay, and real image is always found to be inverted. Okay, so like me for instance, okay, when the image on the screen, now it will be inverted. Okay, my top, okay, actually will be at the bottom. Okay, so however for virtual image, it is always erect. Okay, now image also, okay, like there's an inverted image and a laterally inverted image. Okay, now inverted image is, okay, when the top of the object, okay, and then suppose, okay, there's a mirror and then this is the image. Okay, now what happens, this top actually will become the bottom. This is the object, but this is the image. Okay, doesn't mean, okay, this is object, this is image, bottom, top will be the bottom, okay, and the bottom will be the top. Okay, that is what it means by inverted image. Actually what happens, it flips through the horizontal axis. Okay, and this phenomenon is called inversion. However, for laterally inverted image, okay, now this is when your left becomes your right and vice versa. Okay, and this phenomenon is called lateral inversion. And what happens, this is actually it flips through the vertical axis. Now you will observe mainly this in a plane mirror. Now suppose you wave your left hand, you will find that in the mirror actually your right hand is waving. Okay, that is laterally inverted image. I hope students you have understood for today's class. Next class will be doing more about mirrors and the types of mirrors and its ray diagrams. Thank you.